Hello students, welcome to TIME online classes. Today we are going to study the topic differential equations. In this topic we are going to study linear differential equation. Let me explain what is linear differential equation and how to solve linear differential equation. Let's just have a look. Linear differential equation. An equation of the form dy by dx plus py equal to q is called a linear differential equation, and the peculiarity is p and q will be functions of x only. Functions of x only. So such equations are called linear differential equation. Now let us see how to solve these equations. Whenever you are given a differential equation, you have to write it in the standard form, that is dy by dx plus py equal to q, and identify what is p and what is q. Once we identify p and q, we have to find out integrating factor. Integrating factor is denoted by IF. Integrating factor is denoted by IF and is given by e raised to integral p dx. So we have to identify p and write e raised to integral p dx. And the solution is given by, solution to this equation is given by y into e raised to integral p dx equal to integral of q into e raised to integral p dx. So this will be the solution of linear differential equation. Now let's just look at a problem based on this. Our first question is, an integrating factor of the differential equation dy by dx plus 6x square y by x cube minus 1 equal to 4x by x cube minus 1 the whole square is. So here when you compare this given equation with dy by dx plus py equal to q, we can see that p is equal to 6x square by x cube minus 1. So we can find out the integrating factor using this p. Now integrating factor IF is given by e raised to integral p dx, that is e raised to integral 6x square by x cube minus 1 dx. To integrate this, let us substitute u is equal to x cube minus 1. If u is equal to x cube minus 1, du by dx will be 3x square. So du is equal to 3x square dx. But we want 6x square. So I am multiplying by 2 on both sides. So 2 du is equal to 6x square dx. So that our integral becomes, integrating factor is equal to e raised to integral 2 du by u. Now integral of 1 by u is log u. So let us write e raised to 2 log u. Now n log a is log a raised to n, so we can write e raised to log u square. Now e to the power log will get cancelled, so that your integral becomes u square, where u is x cube minus 1. So x cube minus 1 the whole square. So we can see that the integrating factor is x cube minus 1 the whole square. So our required answer is option B. So please note, we have to find out the integrating factor using the formula e raised to integral p dx. So first we have to write the given equation in the form dy by dx plus py plus q, and then identify what is p. Once we get p, we can find out the integrating factor. So here in this case, the answer is x cube minus 1 the whole square. Let's work out one more similar problem where we have to find out the solution of a differential equation. Consider this equation. If y is equal to y of x satisfies the differential equation, dy by dx plus y cot x is equal to cos 2x. Y of pi by 2 equal to 1, and we have to find the value of y of pi by 6. So first we have to solve this equation and write the general equation, and in that we have to substitute pi by 2 and find the value of c, and then we have to finally find out y of pi by 6. So first let us start with finding the integrating factor. So given that dy by dx plus y cot x equal to cos 2x. So identifying p and q, here p is cot x and q is cos 2x. So integrating factor is e raised to integral cot x dx, which is e raised to log sin x. Integral cot x is log sin x, so e raised to log sin x. So we are getting e raised to log will get cancelled and the integrating factor will be sin x. So we are done half the way, that is we have already found out what is integrating factor. Now we have to solve this equation. So for solution, let's take y into, you have already seen y into, the solution is y into e raised to integral p dx equal to integral of q into e raised to integral p dx. This is the equations or the solution of the differential equation. So we are going to find out this solution first. So we have y into e raised to integral p dx is sin x equal to integral of q. Q is nothing but cos 2x into e raised to integral p dx, which is sin x dx. Now we already know the formula for cos 2x into sin x, cos a sin b, which is equal to 1 by 2 into integral sin a plus b minus sin a minus b. So let me write sin 3x minus sin x. Let's integrate this. Now integrating we get y sin x equal to half into integral of sin 3x is minus cos 3x by 3, and integral of minus sin x is plus cos x plus c. Now let us substitute y of pi by 2 equal to 1. For this, when x is equal to pi by 2, y is equal to 1. So substituting we get 1 into sin pi by 2, which is 1, equal to 1 by 2 into minus cos 3 pi by 2, which is equal to 0, 0 by 3, which is 0, plus cos pi by 2 is also 0 plus c. So from this we get c is equal to 1. So your equation becomes y sin of x equal to half into cos minus cos 3x by 3 plus cos x plus 1. Now we have to find out y of pi by 6. That is, whenever x is equal to pi by 6, we have to find the value of x. So let us find the value on the next slide. So when y is equal to pi by 6, we get like this: y into sin pi by 6. Sin pi by 6 is 1 by 2 equal to 1 by 2 into minus cos 3 pi by 6 divided by 3 plus cos pi by 6 plus 1. Now we have y by 2 is equal to 1 by 2 into cos pi by 2. What is cos pi by 2? 0. So the first term becomes 0 and this term is cos pi by 6, which is root 3 by 2 plus 1. So we get root 3 by 4 plus 1 equal to y by 2. Let's cross multiply by 2. So we get y is equal to root 3 by 2 plus 2. So the required answer is option D. So let me explain once again. We have to find out P, or we have to identify P and Q and find the integrating factor. The integrating factor is given by e raised to integral p dx, and then solution will be y e raised to integral p dx equal to integral q into e raised to integral p dx dx. I hope you enjoyed the session. Thank you.